Welcome to part 4 of our video presentation on Tutorial D. In this part I will show you how to use the solver feature of Microsoft Excel in order to find an optimal combination of trucks and tractor trailers so that your overall cost is minimized. Now, in order for you to use the solver feature, you need to go to the Data tab, and there you will see a sub-pane called Analysis, and this is where you activate the solver feature. Now, a lot of inputs are already entered, so I'll just walk through them so that you know what each of those inputs means. If for some reason you don't see the solver icon here in the analysis subpane, then it can mean that you need to install or simply activate this feature. Now, for that you need to go to part 1 of our Tutorial D video presentation, where I make some comments on how this can be done. Okay, so once you click the solver button, you need to set the objective. Now, the objective is set as this cell, meaning this is the cell you need to optimize. More specifically, you need to minimize the cell based on different combinations of trucks and tractor trailers. So you minimize the value of the cell by changing values of these cells, and they're already highlighted. Okay, so you change values for trucks and tractor trailers. Now, the specific algorithm, or the specific method that you will use is called a simplex LP. LP stands for linear programming. Basically, this method works well when the combination of parameters in your Excel model is linear. Now, in our case, it's linear, meaning the value for cost is a linear combination of other factors. So there are no complicated relationships. It's all calculated based on a linear combination of those factors. So in that case, this simplex method algorithm should work okay. And also you can check some of the options for this algorithm. Now, this is the precision that you will use. The calculation precision. Here, for integer optimality, you can enter the value of 0. Basically, it means if you're constrained, for example, if you have a complicated model and you're limited by time or processing power of your computer, you may want to enter like a non-zero number, let's say 1%. So basically, it means the solver can stop within the 1% of the optimal value. So it will give more freedom for the optimization algorithm, and that's likely to minimize the computing resources. But in our case, since we have a simple model, we'll put 0. Now, here you can also enter max time and maximum iterations for the algorithm to process our model. So we'll put max time is 100 seconds and maximum of 100 iterations. But in this specific case, we're not going to reach any of those caps, any of those maximums, because the model is fairly simple. Okay, so we press OK. Now, very important, for your model, you need to enter certain constraints. And you need to enter them one by one, and we'll just go through those constraints. You add those constraints by clicking Add button, and all those constraints have been already added for you. You just need to, we'll just walk through them. Okay? So, if you don't enter those constraints properly, then the solver will find solutions that, mathematically speaking, are correct. However, they are not correct when it comes to your specific case. For example, if you don't specify certain constraints, solver may want to enter decimal point for trucks. Let's say they will say you need to use 1.2 trucks for Philadelphia store. Now, you know that this is not possible. You cannot use 1.2 trucks. You either use 1 truck or 2 trucks, but not 1.2 trucks. It's impossible, given your case scenario. Also, for example, another example that seems to be makes sense mathematically but doesn't make sense in real life is that the solver may enter a negative value to find minimal cost. Or it will assign 0 value, saying, well, 0 means no trucks are allocated, no tractor trailers are allocated, so we'll put zeros here, and the cost is minimized as 0 for all stores. Now, that's not a realistic scenario given your case. So that's why you need to enter all those constraints. And if you forget some important constraint, then you may get a result that is a bit weird, that doesn't seem to be right, given the kind of scenario that you have. Now, the first constraint is this. These values have to be integers, cannot be decimals. The second constraint is that each of those values has to be greater than 0. Okay? Greater or equal than 0, so cannot be less than 0. The third constraint is that the sum of all trucks that you assign for this particular week has to be equal or less than this cell. Now this cell basically is the total number of trucks that you have available. So that's the cell that is specified here as a constant. Now this one is similar to the previous one. Basically, all of those values have to be integers. All of those cells have to be integers. Again, all of those cells have to be equal or greater than 0, cannot be a negative number. So basically you cannot assign a negative number for tractor trailers here. And this is similar to the previous example again, where we're saying that the sum has to be less or equal to cell F6. F6 is this cell. So basically what we're saying, we cannot assign more tractor trailers than we have available. And here we have other constraints. First of all, we're saying this value has to be greater or equal than this value. So basically means that the total capacity that we allocate for this particular store has to be equal or greater than the required capacity. So that's the cell that is specified here. And then we do it for all other cells. We're saying, for all other stores, we're saying the capacity that we allocate has to be equal or greater than the required capacity. So we enter all those values, and then we just press solve. You see it took us, 1 or 2 seconds to find a solution. When you see the screen, what you can do, first of all, you can keep the solver solution. They're entered right here. And you can also generate an answer report, so where you'll see some details about the solution. So you press OK. So first of all, here we have here we have values for this ideal combination where the cost is minimized. Also, you see that our constraints have been met. The capacity utilization is good. It's in the 90s, right? So it means that we're using almost 100% capacity, but not quite, because sometimes it's hard or impossible to use 100% capacity. And this is the cost. Now, if you look at the answer report, you see like the header that summarizes the solution. The various parameters of the solution. For example, the algorithm or the method that we used, how long it took us to find a solution. Here we have a original value. Here we have the final value. Here we have like a summary of variable cells and their original values. So just look at some of the aspects of the solution. But here we have our final output, which is the cost that is minimized, giving the combination of trucks and tractor trailers that we're using. So this concludes part 4 of our video presentation on tutorial D. Thank you for listening.